Hi everyone, this is our physics project on a scene from Matrix Reloaded. So in that scene from Matrix Reloaded, Neo saves Trinity by stopping her downward motion and accelerating her perfectly horizontally almost immediately at a very high speed. So we're trying to figure out A, whether the force that Neo collided with her with was possible for Trinity to survive, or B, whether the change in direction at the speed at which she was going with was something that wouldn't be damaging to her. So in order to do that, we needed to gather the following data. We looked up the weight of the actress that plays Trinity and found that she weighed 57 kilograms at the time of the shooting. The actor who played Neo weighed 84 kilograms. Also, because of the boom that we hear right before Neo saves Trinity, it's implied that he's breaking the sound barrier and going at a speed of 343 meters per second. Finally, from timing the video from when Neo starts flying to when he saves Trinity, we found that it took 5.4 seconds. That's the value of t that we're going to use to solve the acceleration for Neo.
We need to find the force of Neo on Trinity. We will use the equation F equals ma. The actor for Neo weighs 84 kilograms. To find acceleration, we will use the first kinematic equation v equals v naught plus at. V naught equals 0, v equals 343 meters a second, which is the speed needed to break the sound barrier, and time is 5.4 seconds. We got 5.4 seconds for time by timing how long it took Neo to catch Trinity after breaking the sound barrier. After filling in the variables we have, we get 343 equals 5.4a, and we will get 63.5 meters a second squared as acceleration. Going back to the first equation, F equals ma, we multiply 84 kilograms by 63.5 and get a force of around 5,334 newtons to the left, or F equals ma. The actor for Trinity weighs 57 kilograms. Acceleration in this case is Earth's gravity, which is 9.81 meters a second squared. We will multiply 57 kilograms by 9.81 meters a second squared to get a force of 559 newtons in the negative y direction. Lastly, to find a net force vector, we will square both vectors from before. We will take 5,334 squared, add it with 559 squared, then take the square root to get 5,360 newtons. To find direction, we will use sine of theta. Sine of theta is equal to 559 over 5,360. To find the angle, we will use the inverse, so theta equals cosecant of 559 over 5,360. After solving, we will get an answer of theta equals 5.99 degrees. In this case, it is 5.99 degrees south of west. So our net force vector is 5,360 newtons, 5.99 degrees south of west.
In an inelastic collision, while momentum is conserved, kinetic energy is transferred elsewhere. When Neo and Trinity collide, they both end up moving in the same direction, even though prior to the collision, they were both moving in different directions. Another example of this would be a car getting T-boned. After the collision, kinetic energy would be transferred from one car to the other, effectively slowing down the car while moving in a different direction.
Neo and Trinity had what is known as an inelastic collision. In said collision, while momentum is conserved, kinetic energy is transferred elsewhere. When Neo and Trinity collide, they both end up moving in the same direction, even though prior to the collision they were moving in different directions. To solve, we used m1v1 plus m2v2 equals m1 plus v2 to the quantity of Vf. In the x direction, m1, which is Trinity's mass, is 57 kilograms. m2, which Neo's mass, is 84 kilograms. v1, Trinity's velocity, is 0. v2, Neo's velocity, equals 343 meters per second. Solving, Vf is 204. In the y direction, masses remain the same, Trinity's velocity is unknown, and Neo's velocity is 0. We know that Trinity fell 66 floors and that each floor is 14 feet, so that's 282 meters. And solving, v equals 74 meters per second. We plug that back into the inelastic equation, and we get 30 meters per second for Vf, which means that the total magnitude is 204 meters per second.
And for the final verdict, is this realistic or not? The answer is no. Neo's force colliding with Trinity falling is 5,334 newtons, which is too much for someone to survive. It takes 4,000 newtons to break a human bone. The total force of 5,360 newtons is also too much force exerted on someone to survive. The angle of 5.98 proves that it is impossible for Neo to have continued traveling perfectly horizontally after saving Trinity like he did in the video. The almost instantaneous change in direction on Trinity at such a high velocity, the speed of sound, would cause her neck to snap as well as break multiple bones.
So, unfortunately, in the end, if we were to apply the physics of real life to the Matrix Reloaded, Trinity would not be able to survive the impact of Neo attempting to rescue her. This has been Physics Analysis of The Matrix Reloaded, and thanks for watching!